All right, we're going to be talking about the average atomic mass of elements. Okay, and this is actually a very important number. It is very important for calculations. All right, super important for calculations, especially later on when we're getting to really tricky things like stoichiometry, limiting reactant, all that good stuff. We're going to be using average atomic mass, okay? And the average atomic mass is going to be the mass that's listed on the periodic table. And yes, this one has decimals. So if I get my beautiful periodic table here, and hopefully that focuses, bring it up a little higher, all right? This atomic mass is going to be listed on your periodic table. All these mass numbers, right? The ones that have decimals, okay? Those are your average atomic mass numbers of these different elements. We'll talk about how to calculate them right now, but you can see that they do actually have decimals, right? Okay, so it is slightly trickier to calculate average atomic mass, okay? Because it's not just an average of your different isotopes, okay? Womp, womp, womp. It is a weighted average, okay? So your average atomic mass is actually weighted. And what does that mean? It just means it takes into consideration the abundance of these different isotopes, okay? So it takes abundance into consideration, which just means kind of how often you find a specific isotope in the world. All right, we've defined it. Let's actually do an example because hopefully that will make more sense. We'll do an example with chlorine, okay? So chlorine has two main isotopes. It has chlorine 35 and it has chlorine 37, okay? So you would think if we're talking about average atomic mass, right? I'm taking an average. So I would take 35 plus 37 divided by 2, and I should get the average atomic mass of chlorine, ta-da, is 36. Yay! Except no. Here's my chlorine, right? Average atomic mass is not 36. It's 35.45. And that's because it's not just a straight average. It is a weighted average, okay? What the blank does that mean? So that means for chlorine 35, it has an abundance of 75.53%. Should have written this slightly below. All right, there we go. Okay, so I find chlorine 35 75.53% of the time on the Earth. Okay, hooray. For chlorine 37, I find that it has an abundance of 24.47% on the Earth. Okay, so there are more chlorine 35s than there are chlorine 37s on this world, which means we need to weight their different masses. Okay, we need to weight them. All right, and then you also get a thing called relative mass. We don't need to necessarily figure out how to calculate this. It will just be given to you in any problem that you have trying to calculate average atomic mass, okay? But you're not going to get an exact mass of chlorine 35 being 35.00000 and on forever and ever. You're going to have a relative mass. So it's just going to be, you know, it's going to have a decimal point. It's going to be rounded. So the relative mass of chlorine 35 is 34.97. The relative mass of chlorine 37 is 36.97. So we have these two isotopes, we have their abundance, and we have their relative mass. Now, what the blank do we do? Okay, so how do we calculate? The way we calculate average atomic mass is that you take the abundance. All right, let's write this out. Average atomic mass is going to equal the abundance as a decimal times the relative mass of isotope number 1 plus the abundance times the relative mass of isotope number 2 If you had 3 isotopes, you do it a 3rd time. If you had 4 isotopes, you do this a 4th time. Okay, yuck. All right, so this right here is for isotope 1. This right here is going to be for isotope 2, and you would go on and on and on for however many isotopes you had. God forbid, if you had 17 isotopes, you would do this 17 times, okay? I would never make you do that in a quiz or a test, but just so you understand. Okay, so if I was going to solve this problem, let's use a different color, my goodness, all right? So if I was going to solve for the average, okay, my isotope number 1 is my chlorine 35. The abundance is 75.53%. I need to change that to a decimal, right? So just whoop, whoop. Move my decimal place 2 over. So I'm gonna have 0.7553. That's my abundance. Times, there we go, times my relative mass is 34.97. Okay, so I have this calculation plus the exact same thing for my isotope number 2. So for chlorine 37, its abundance is 24.47%. So I need to change that to a decimal. So move that decimal over 2 places. So 0.2447 for my abundance of this isotope times the relative mass, which should be given to you, 36.97. Okay. So now I have these lovely calculations, and you just boop, boop, boop into your calculator. And you get that your average is going to be, these 2 numbers multiplied by each other, is going to be 26.41 plus 9.047. Okay, 4 sig figs for each one. And if we add them together, you get your total average of being 35.45. And if you look at your periodic table, there it is, right? For chlorine, it is in fact 35.45 for the average atomic mass. Okay, so it's more complex than just averaging your 2 isotopes, unfortunately, but at least now you know how to do it. And now you know why there are decimal points on your average atomic masses on your periodic table. Okay, this doesn't mean that there's 0.45 of a proton somewhere in the world. This means that I've taken into consideration the abundance and the relative mass of all of the different types of isotopes for this element. Okay, hopefully that helps and doesn't confuse you more. All right.